Hi everybody, welcome back. So I think we have had a lot of really cool stuff on the Twitch stream today. I am excited to be here with Anil and Darryl from EFS, and I was hoping that we could kind of close out most of the sessions here by talking about one of our coolest products, which is EFS. And EFS stands for Elastic File System, right? But I think many of our viewers probably don't know about it. So could you give us a short description of it and kind of introduce yourself as well?
Sure. My name is Anil Gunturu. I'm a product manager on the EFS team. Just a short description of EFS is a simple, elastic, scalable, shared file storage that customers can use to access from multiple EC2 instances.
So it's kind of like a shared file system, as you said. Do I access it over like NFS?
Correct.
Awesome. So how long have you been at AWS?
I've been at AWS for 2 years.
2 years, you're a regular veteran then.
Yeah.
And what is your role here at AWS?
Yeah, my name's Darryl Osborne. I'm a solutions architect with Amazon File Services, so I work exclusively with the EFS team.
So you probably have a lot of customers that you have seen
I
deploy this.
have, and I hate to tell you how long I've been at AWS. So it's a little more than 2 years. I'm just about 6 years so far. So
wow,
long time.
You've got
seen a lot of changes over the years.
New badge color and everything.
I do, yeah.
That's the fancy thing. Internally, after you've been here for 5 years, you get a fancy new badge color. And if you're here for 10 years, it's an even fancier badge color. And then at 15 years, you get an even fancier badge color.
Yeah.
I don't know about 20 years.
I don't know, I haven't heard.
So I think we've got some sort of conception of what EFS is, right? It's this shared storage out in the cloud. We don't have to think about any of the underlying infrastructure. We don't have to think about any of the kind of underlying components. We just kind of mount it as a volume and we access it, read, write, all that good stuff across as many instances as we want. But I understand that we had a pretty important launch today, something that our customers have been asking us for some time. And could you tell me a little bit more about that?
Sure. Last week, we actually announced provision throughput for Amazon EFS. So before provision throughput, customers, the throughput of their file system scales with the amount of data stored in the file system.
Similar to like the GP2 volumes on EBS, Elastic Block Store, the more data you had, there, the more performance you would get, the more IOPS essentially you would get. But
Correct.
This model that you're talking about, the provisioned IOPS model, that's more similar to EBS's provisioned IOPS,
right.
Where you can basically scale a volume of 1 gigabyte if you want up to 20,000 IOPS or something.
Right. So the difference here is the customers can actually provision the throughput independent of the storage in the file system, and they can do this immediately, and they can get the consistent performance. I say immediately because they can actually use the CLI and the console to quickly change the throughput and get the throughput required for the file system.
So even after you've provisioned the file system and everything and it's connected, you can actually scale the PIOPS up and down?
Right, so in case of EBS, we refer to that as PIOPS,
Yeah, so this provision
but in EFS world, we talk about provision throughput. So once you created the file system, you can actually provision the throughput for the file system, and you can actually increase the throughput of your file system as often as you want. So let's say, for example, you're running a workload and you realize that, oops, I needed higher throughput. So you can always increase the throughput to meet your application's workload requirement.
And you don't need to answer this question, but I always try and push the product teams to kind of see and fill out if I can get some secret info for our Twitch audience here. Things like DynamoDB have auto-scaling of their read and write capacity. So I was wondering, is there going to be some sort of feature where we could look at the, maybe I/O wait times or something on the volume and auto-scale for more provision throughput? Do you think that's in the future? Is that something that anybody's asked for?
That's a very interesting idea, and we get this feedback frequently, so...
that is the correct answer. So, you mentioned that you can modify this with the AWS CLI, you can modify it in the console. Could we get a demo of that?
Yeah, let me show you.
Awesome.
So, if we take a look at my screen, I actually have an EC2 instance that I've SSH'd into. I have two windows. I have the top window, the bottom window, same instance. We do a simple df command, we'll see that I have an EFS file system mounted on this instance. So So what we want to do is let's go ahead and just run a simple command. We're going to run a read command. We're going to use IOPing, open source tool. So let me go ahead and grab that, that operation. And in this example, we're going to be reading in 8K blocks. So in the bottom, let's go ahead and open up our endload utility. And we'll see that we were getting around 3 megabytes per second throughput. So if we wanted to go ahead and increase this, we could. So now this file system is running in bursting throughput mode. So the throughput of the file system is based on the size of the file system. If we take a look at our DF, we don't have any data in this file system yet. So we're really getting the minimum burst throughput of a file system, which is 100 megabytes per second.
Okay.
So let's say though we had an application that required more throughput, but we don't have the underlying data for it to actually increase in size. What if we could actually provision throughput for this file system and increase it on the fly? So let's go ahead and do that. So with this command, let's go ahead and change the size of the request from 8K to 64K. And let's see what type of throughput change would come about.
So we're just changing the block size that
We're just trying to change the block size right now.
And maybe this is a technical sidebar, but do we need to set any sort of mount options, like no A time or any of that sort of stuff? Are there any best practices here?
So we do, yes. We actually have an EFS utils that has all of our recommended mount options sort of built in. So all you have to do is use our EFS mount helper, mount the file system, and all the optimal mount options are included.
I had years running different databases and figuring out the right options and block sizes and read ahead and all that stuff.
We've done all that for
I
our
love
customers.
that. That's awesome.
So if you take a look at the screen, we're able to get 22.3 megabytes per second by just increasing the request size. So what if now we actually have multiple threads running this command and actually increase the thread size a little bit more and ran it for longer and then changed the throughput from bursting throughput mode to provision throughput mode.
Okay.
So in this command, we're actually going to change the request size to 128K. We're going to run 16 threads instead of a single thread. And we're going to run it for 5 minutes. So let's go ahead and kick this off. We'll see down below how much throughput we're able to drive this file system. So we see around 100 megabytes per second throughput. That's the minimum burst throughput that a brand new file system is able to achieve.
And it looks like we're bursting just a little bit above that sometimes, which is nice.
Yeah, but what we want to drive more. This application is able to drive more, but right now we can't. So let's go ahead and change it to provision throughput mode and change the provision throughput to say 128 megabytes per second.
Can we go higher?
We could go higher. We can go higher. So what do you want to do? 256?
Yeah, let's do 256.
Okay, let's do 256.
Go big or go home.
That's right. Let's do
One
it.
of the chief reasons that I continue to work at AWS, aside from the amazing pace of innovation and my complete addiction to new features, is that I don't have to pay my own AWS bill.
That's right. That's great. So here's the update file system. I could do this from the console or from the CLI. It's just a CLI command. I'm going to go ahead and run this on my local instance. So if we hop back to the other instance, we'll see that in a few seconds, we're going to see the throughput of the file system spike up. So right now, we're still at around 100 megabytes per second. My application is able to drive more, and we'll see that here. Now we're up to
it's
200.
going right up.
So Darryl, how can I check the throughput of my file system?
So you can check the throughput of the file system using CloudWatch. So we actually have CloudWatch metrics that we expose to customers. They can create a dashboard or just create a graph and take a look at the total I/O bytes. Now, one of the great features that the CloudWatch came out with earlier this year was metric math. And now you can actually create a math expression in your graph to show you in megabytes per second how much throughput your file system is achieving.
You can put it on a fancy dashboard, you could set an alarm on it, and then maybe you could have a Lambda function trigger on that alarm and tell EFS to scale up or scale down.
You can. So one of the great things is we actually have an EFS tutorial out on GitHub that has a dashboard created. It's a simple CloudWatch CloudFormation template. Throw in the file system ID, and within a minute, you have a nice dashboard ready to go.
I love it. That's the way to do it. So we have a couple questions from the stream. Stunt Badger is asking if EFS will arrive in London anytime soon.
So we're looking at expanding EFS to all of our regions. We're excited. We want to get it out to all of our AWS regions. It is coming in the future.
So maybe it's better to take a quick step back and think about what are customers using EFS for? Like what kind of use cases do we have?
Yeah, so a wide spectrum of use cases, anywhere from web applications, web serving, to CI/CD tools, software development tools, to enterprise applications, data analytics, big data, even database backups is a big use case that we see customers use EFS for.
And we have a quick question from the stream, and then I'd like to hear a few more customer use cases.
Yeah.
Maybe some name dropping if you're able to do that, I don't know. So Face Knight is asking, what's the compliance like for EFS? You know, is it HIPAA compliant? Can you use it in other kind of situations?
Yeah. So we are HIPAA eligible service. So customers with BA agreements can store healthcare related data there. Just last week, we also announced PCI DSS compliance.
Nice.
And we're also getting feedback from customers about other compliances. So we're constantly prioritizing our roadmap for future compliances.
So as a part of that, a file system can be created as encryption of data at rest. So all of your data and metadata is encrypted at rest. You can also mount a file system and enable encryption of data in transit as well.
And do people ever, one of the things that I've done with EBS volumes in the past is I've created kind of these these LVM kind of partitions, and I've used like loops and encryption there. But that's not really necessary with EFS, is it? Because that's really what's happening way behind the scenes, and I don't have to worry about it. As far as I'm concerned, it's just a block storage device, right?
Right. It's a highly available, highly durable network file store.
So when you say that I can encrypt it at rest, does that mean I use KMS keys?
We have integration with KMS, and you can have AWS managed CMKs or customer managed keys, or customer managed CMKs.
Awesome. So are there any customers that have made tremendous use of this provision throughput feature yet? Have we seen it? What are our limits? Like how far can we scale? What can we do?
Yes. So customers can provision up to 1 gigabyte per second.
I like it.
In all regions, and that's a soft limit actually. If they require higher throughput, they can actually reach out to us, and we can work with the customers on a case-by-case basis.
And I can do that through a support ticket or
correct
account manager, that sort of deal?
Yeah.
Awesome. I just have so many ridiculous scenarios in mind. Most of them involve my giant collection of selfies, which absolutely needs either a ZFS wheel or some NFS cluster to host. There's really no other way to store that amount of data. And I was thinking all of my EC2 instances, this is actually pretty useful for some machine learning use cases too, now that I think about it. You could probably bring in a container and say, hey, I want you to add in this EFS mount and pull all my data from there. And you could do multiple different training jobs. So instead of, SageMaker just added in this pipe mode where you can pull from S3, but let's say that data is, has a little bit of read and write and churn and stuff, you could actually say, hey, I want you to mount this EFS component or this EFS storage, and then I want you to pull all my data in, and I want all of the different nodes to be able to access that. Yep. And I'd like to see maybe, a framework that could take advantage of that shared storage layer. Because I don't think many machine learning frameworks do that yet. That's something not related. Sorry, my weird tangent.
That's a good point, actually. We already have quite a bit of customers actually using EFS for big data and analytics.
Yes.
So we can envision customers using EFS file systems to run their machine learning algorithms. So that's a very valid use case, actually.
Awesome. So Sejak has another question about what is the impact of encryption on the speed, and does it have any additional costs?
Yeah, so there's no cost for encrypting a file system at rest or in transit. Negligible performance impact.
Right. I think a lot of the encryption stuff, as we've gotten more modern processors and more modern instruction sets, a lot of that encryption cost has kind of gone away.
Right.
Because it goes right down to like the individual registers and like the individual instructions on the processors now.
Yeah, and it's really optimized for that today. So,
what kind of like other things have we announced besides provision throughput in the recent past?
Sure. Actually, we had a very exciting week last week. Actually, we had like 3 consecutive announcements. One was we announced EFS in Tokyo, Japan region.
Awesome.
And then we announced provision throughput. And immediately the next day, we announced PCI DSS compliance.
You guys are on a roll.
Yeah.
And what about from maybe the previous quarter or even around the reInvent timeframe? Any kind of...
Sure. Actually, in the previous quarters, we announced encryption of data at rest, followed it by encryption of data in motion. We also announced a new feature for our customers called EFS File Sync that enables our customers to move data from on-premises onto AWS Cloud in an easy fashion. Faster, 5 times faster than any of the tools that are available today.
So what exactly is File Sync and how does that work?
So let's say you have a lot of data in your on-premises and you want to move data into EFS file systems. So you can actually use File Sync to move data 5x at 5 times more speed than any of the available tools. Like for example, if you use rsync or CP, those are all single-threaded applications, but EFS File Sync leverages multiple threads and is able to move data much faster into AWS. And it also doesn't require a VPN connection or a direct connect connection because it uses a secure channel to move the data.
How is it making those sort of performance gains? Is it doing block by block or something instead of file by file? Or?
So basically, if you look at the architecture of EFS, right? EFS is a distributed architecture. When you have applications actually doing things in parallel, like copying things from multiple threads, you'll actually see higher performance. So EFS File Sync is actually what it is doing under the hood. Is it's actually instantiating multiple threads to actually copy data onto EFS.
Excellent. Okay. So we've talked about EFS, we've talked about provision throughput, file sync, the different compliance regimes that are now available. Is there anything that you want our customers and our viewers to know before we kind of sign off and kind of start to close out the session for the day? Don't go away, we have one more thing after this, but anything else that you think our viewers should know about?
So we constantly get feedback from our customers. So we have a very long list of things that we want to do, and we are constantly innovating on behalf of our customers. So as you have seen in the past week, our pace of innovation is very fast, and we expect to continue that. And we also expect to be in more regions as we go forward.
Well, I would be happy to write a blog post about any new features, so be sure to shoot me an email. I think that is going to be it for this session, unless you have anything else that you want to add?
I don't. So one thing we have created is the Amazon EFS tutorial that we have out on GitHub. It's a great way for customers to actually walk step by step through some tests that we've created, so they can see firsthand how to actually, how parallel operations will benefit their application.
Awesome. All right, well, I think we're going to move on to the next section. So thank you both so much for coming on the stream. I hope we will see you again at reInvent, and maybe even before then. We'll be back in just a bit.